Hello class, today we're going to be learning lesson 5-3 in your algebra books. It's titled Solve Multi-Step Inequalities. So the past 2 days we've been discussing how to solve inequalities with just one step. It was either addition or subtraction, or the next day we learned about multiplying and dividing. And so what you're going to do today is solve just like you solved multi-step equations, okay, when they had an equal sign, but you need to remember, because of inequalities, you're going to flip the inequality if you multiply or divide both sides by a negative number. That's kind of the difference for any of the rules that we had between solving equations and now solving inequalities. So let's practice with a very simple one. We have 3x minus 7 is less than 8. So we're going to solve it the same thought process that we used when we had an equation, by first getting rid of the lonely number away from the variable. So since it's subtracting 7, instead I'm going to add 7 on both sides. And now I'm left with 3x is less than 8 plus 7 is 15. Now one more step to get the x by itself. Instead of multiplying by 3, I'm going to divide by 3 on both sides. My 3's cancel out, and I am left with the inequality x is less than the number 5. Okay, very basic. I wasn't dealing with any negative numbers there. So to graph it, because I do have my variable on the left-hand side, it is much easier to graph it. So all the numbers x that are less than 5, which means it cannot be equal to 5, but it can be any of the numbers that are less than 5. So I'm going to shade any of those possible solutions for this inequality. So that's going to be pointing to the left-hand side. So I have another one already set up. This time it says solve and graph negative 7x plus 2 is less than negative 5. So again, I'm going to focus on that lonely number. This time it's adding 2, and I want to get that away from the negative 7x. So instead of adding 2, I'm going to subtract 2 on both sides. And the 2's will cancel out. I'm left with negative 7x is less than negative 7, right? Negative 5 and negative 2 become negative 7. So now I'm going to divide both sides by negative 7 to get the x by itself. Those will cancel out, and I'm left with x. And remember, because I'm dividing both sides by a negative number, I'm going to flip my inequality. And negative 7 divided by negative 7 is positive 1. So I'm going to just put that note here, remind you to flip that inequality, because you are dealing with dividing by a negative number on both sides. So now I can graph it on a number line. 1 and 2. On the other side, negative 1, negative 2. And it's up to you what numbers you want to include on your number line. It is not equal to 1, but it's all the numbers that are greater than the number 1. So it's going to go in the direction of the positive numbers to the right that are all bigger than positive 1. Now we know that not all of our inequalities are going to look like this. Some are going to get even more complicated. So I have some set up already for us. The first one that we're going to solve and graph is the inequality 1/3 times, in parentheses, 3x plus 6 is greater than or equal to negative 1. Now when I come across this, there's two different ways that I can get rid of this 1/3 fraction. The way that I'm going to show you right now is by using the distributive property. So 1/3 times 3x is actually just x, because the 3's will cancel out, plus 1/3 times 6 is just 2, because the 6 divided by the 3 will become 2. And that's going to be greater than or equal to negative 1. Now this looks very similar to the problems that we just did. I want to get the x by itself, so I'm going to subtract the lonely number, which is 2 on both sides. And then I'm simply left with x is greater than or equal to negative 3. because negative 1 plus negative 2 is negative 3. I'm going to draw my number line. I'm going to go by 3's this time. And because it says x is greater than or equal to, oh, that should be a 6. I'm sorry about that. Because it says greater than or equal to, I am going to shade on the negative 3, but it's going to be any of those numbers that can be larger than negative 3 as well. Those will be all of my possible solutions for this inequality. Now, this next time, you're going to notice that we have variables on both sides of the inequality. So what we had before for our rules was combining the variables on one side. I like to put them on the left-hand side, and then moving all of the numbers to the right-hand side. So I'm going to move my variables first. I'm going to subtract 2x on both sides. 6x minus 2x leaves me with 4x, and I'm going to rewrite everything. Minus 7 is greater than or equal to 17. And now this looks like the problem that I just have been doing. So I'm going to add 7 on both sides because now I want to move my numbers away from the variable. And I'm left with 4x is greater than or equal to 17 plus 7 is 24. So for my final step, I can divide both sides by 4 because I want to get x by itself. 4's cancel each other out, and I have x is greater than or equal to positive 6. So I'm going to draw my number line. And again, it's up to you what kind of numbers you want to include on your number line. If you want to go by 1s or by 2s, in this case I'm going by 3s, it can be equal to 6, so I'm going to shade on the 6, and it's all of the x values that are greater than or equal to positive 6. So this as well is going to go to the right-hand side. All right, I have one more set up for you. And again, there are variables on both sides. So why don't we check this out? I'm going to do the distributive property first. So when I do that on the left-hand side, I have 3 times 3x, which is 9x, plus 3 times 2 is 6, is less than or equal to 6x plus 21. Like I did before, I'm going to move my variables first to put them on the same side. So I'm going to move my 6x to the left-hand side. I'll do that through subtraction. 9x minus 6x is left with 3x. Rewrite everything else that I have left, so plus 6 is less than or equal to 21. Now I'm going to move the 6 to the opposite side because I want to get the lonely numbers away from the variables. So I'll do that by subtracting 6. And I'm left with 3x is less than or equal to 15. I'm sorry, I thought I heard a noise. So 3x is less than or equal to 15. I'm going to divide both sides by 3. And x is going to be less than or equal to 5. I still haven't had to deal with many negative numbers, which has been kind of nice. This time on my number line, I'm going to go by 5s. Again, it's completely up to you. X is less than or equal to 5, so it can be equal to 5, but this time, because it's all the numbers that can be less than 5 as well, I'm going to shade to the left-hand side. So I've done many inequalities now with multiple steps. So sometimes you're going to find that the answers are actually a little different than what we just came up with. So let's read what I've written here. After you solve an inequality, if you eliminate all of the variables, which might happen sometimes, and you're left with a true inequality. True inequality means when you read the inequality you're left with, if it's true, such as how negative 3 is really less than 0, that's true, then the solutions of the inequality are all real numbers. Which means it can be any of the real numbers. Okay, we're not going to be limited. But if you're left with an inequality that's actually false, such as if you find 4 is less than -1, we know that that's not true. We know that 4 is really greater than -1. Then that means that the inequality has no solutions at all. So I have two examples here, and we're going to look at them closely. We're going to see if, when we solve the inequality, if we can find any solution. Okay, so I'm left, or I'm not left with, but I'm starting with 14x plus 5 is less than 7 times parentheses 2x minus 3. So what I'd like to do is I'm going to do the distributive property on the right-hand side and rewrite what I have. 14x plus 5 is less than 7 times 2x is 14x, and 7 times -3 is -21. Like I did before, I want to combine my variables. So I'm going to subtract 14x from both sides. And when I do that, I'm actually noticing that I'm eliminating all of the variables. And I'm left with 5 is less than -21. Now, is this true? Is 5 really less than -21? No, it's not. So what I would put here is no solution. If you were going to graph this, you would have your number line, but there would be nothing for you to put on it. There wouldn't be any solutions that you would actually graph on it. It would just be a blank number line. So let's check out our other one. 12x minus 1 is greater than 6 times the quantity 2x minus 1. I'm going to do my distributive property one more time and rewrite it. I have 12x minus 1 on the left-hand side is greater than 6 times 2x is 12x minus 6. I'm missing an x there. Okay, I'm going to combine my variables, so subtract 12x on both sides. The 12x's cancel out, so I'm left with no more variables. I've eliminated all of them. So I'm down to -1 is greater than -6. That is a true inequality. -1 is bigger than -6. So if you were going to graph this, you would graph all real numbers. So on a number line, looks just like I had it before, but I would shade everything. It can be any of the real numbers on this number line, going in any direction. So what I'd like to leave you with now are I have two more examples that I'd like you to practice. I'd like you to solve and graph each inequality if you're able to, and we'll check your answers before you come back to class tomorrow. All right, see you at class.